Hi there, Mr. Lees here doing the SQA Mathematics higher paper from 2019 paper 1, and we're on question 9, where you're given two vectors u and v, and they have components p minus 2, 4 and 2p plus 16 minus 3, 6. And then find an expression for u dot v, and then determine the value of p for which u and v are perpendicular. So let's get that one out the way first of all. So the u dot v is you just multiply each of the x components, the y component and the z component, and you add your answers together. So we have p times 2p plus 16 plus minus 2 times minus 3 plus 4 times 6. So we have 2p squared plus 16p plus 6 plus 24, and that gives you 2p squared plus 16p plus 30. And for part 2, to be perpendicular, for two vectors to be perpendicular, the dot product must be 0. So there's the dot product, set it equal to 0. We're now going to solve this. So we take 2 out as a common factor. 2 times p squared plus 8p plus 15. Factorise that there to give you p plus 5 and p plus 3. And that gives you your two solutions of minus 5 and minus 3. And then for part B, let's just quickly look at the question. Determine the value of p for which u and v are parallel. Well, two vectors are parallel if one is a multiple of the other. Now, just by looking at vectors u and v, and the easiest way to spot it is 4 going to 6 and minus 2 going to minus 3. 4 times what gives 6? 1.5. Minus 2 times 1.5 gives minus 3. So this vector here is that 1 times 1.5. So p times 1.5 has to give 2p plus 16. There we have it there. So p times 1.5 is 1.5p, has to equal 2p plus 16. Take that over, 1.5 take away 2 is -0.5, p is 16. So p is 16 divided by -0.5. And how many halves go into 16? 32 of them. So 16 divided by -0.5 is minus 32. And there's your final answer.